Okay, we're looking at your Alkynes PowerPoint notes. And now we continue. We remember alkanes were CnH2n plus 2. Then we put in a carbon-carbon double bond, so alkenes became CnH2n. We wiped out 2 hydrogen bonding sites. And when we go to an alkyne, we wipe out 2 more, and that's why it's CnH2n minus 2. Like alkenes, these are unsaturated. They have room for more hydrogens. And we have to remember we're going to end up with this wonderful AX2 shape, which is linear. So around a carbon-carbon triple bond, it's always going to be linear. We love alkynes. They're just like alkanes. I hate that diagram there. This is going to be a better diagram. And we see we have 2 carbons. Sadly, the old name is acetylene. We want to avoid that name. That's terrible. So we have carbon-carbon like that, triple bond. And this is the simplest alkyne, 2 carbons. And so we say that has to be ethyne. Eth for the 2 carbons, yne for the triple bond. We don't have to put a location in the triple bond because it could only be between the carbonies. All right, just like alkanes, indicate location of carbon-carbon triple bond only when necessary. And the triple bond takes priority, so we love that. We give it the lowest number. Fantastic. And you can see things came in a weird order. Hate that. Love that. So we find our longest sausage. The longest sausage has 4 carbons in there. So we go 1, 2, 3, 4. We can see it's between the second and third. We can see there's 4 carbons, so that's bute, butyne, butyne. See, it's so logical. So it's called bute because there's 4 carbons in the longest chain. It's called yne because there's a triple bond. Between second and third, there's where the 2 comes from. Boy, the triple bond's always coming in first. Very strange. So we look at this beast. We go 1, 2, 3, 4, 5, 6. 6 carbons in a row, and we say, hey, hex. So hexyne. We know it's a hexyne. Then we go 1, 2, 3. Between the third and fourth. Actually, if we counted from this side, 1, 2, 3, third and fourth. Didn't matter which way we counted from. So this has to be 3 hexyne. So that was pretty easy. That's not so easy. That is a dog's breakfast. Now with a triple bond, we've got to include it. We've got to include triple bond in our longest sausage for this one. So we're going to go thump. And we're going to go thump, and we got to come up around that carbon. This carbon has 4 bonds, 3 there and 1 to this carbon. This carbon has a bond there, a bond to that carbon, and a bond up and down to the other carbons. That makes this a branch, and it makes this a branch. Lowest number, we're going to count from here. So that's our 1, 2, I better not forget that carbon, 3, and then we go 4, that's supposed to be a 4, 5, a 6, and a 7. Uh-oh, and this bromine here is another branch. So I'm going to have 3 branches, the bromine, the ethyl, and I'm going to have a branch and a branch. The fluorine, this is going to be a fluoromethyl. Fluoromethyl. Don't have to put a location for the fluoro because it has to be, there's only 1 carbon it can be on. This is indeed a tough question. Let's see what we get. This is probably going to take up a little space. Holy Toledo. So we go 1, 2, 3, 4, 5, 6. That bromine's off the 6th carbon. That's why it's 6 bromo. 1, 2, 3. The ethyl's off the 3rd carbon. 3rd carbon also has this fluoromethyl. That's the fluoromethyl there. And between the 1 and 2 gives us the 1 heptyne, hep for 7. If you're systematic, this stuff is easy. If you don't try, you're in trouble. If you're not systematic, you're in trouble. So follow the steps. But these things should be starting to click, start to make sense.